Hi, everybody. Today we are going to be talking about 5.2 in our pre-algebra notes, which is going to be talking about the topic of proportions. Okay. So we did 5.1 already, and that was on the topic of ratios and rates. And now we're changing it just a little bit. All right. So what is a proportion? I've used this term already before, but a proportion is going to be an equation. All right. So can think equal sign stating two ratios are equivalent. Okay. And with that, to say something is proportional is similarly in here, they are two quantities that form a proportion. Okay. So let's say we had 2/3, a to make this is a ratio. Another ratio that would be equivalent is 4/6. Now we have two equivalent ratios. We have just formed a proportion. Okay. So a lot of what this section is about is saying whether stuff is proportional or not. And then from there, we'll get into solving proportions and so on, and word problems with that. So we have a first example here. Tell whether 6/4 and 8/12 form a proportion. Well, whenever we're trying to see if something is a proportion or not, we want to again see if two ratios are equivalent. So the easiest way to do that always is to compare in simplest form. Okay, so let's put this 6/4 in simplest form is 3/2. And 8/12 in simplest form is 2/3. Is this equivalent? No. So we do not have an proportion here. Okay. And we can also see that something over one is not going to be equivalent to something less than one. Okay. Our next one here, we have a table, an XY table, all right, of inputs and outputs. And we want to know whether X and Y are proportional. So what we can do here is we can always compare X over Y, or we could do Y over X and simplify it down and see if it works or not. So let's do that. Let's first take X divided by Y, so 1/2/3. Well, 1/2/3 is 1/2 divided by 3/1, which is equal to 1/2 times 1/3, which is 1/6. Okay, so if everything here, when we take X divided by Y, simplifies down to 1/6, we know they're proportional. Well, this first one here, or second one, I'm sorry, 1/6, we know that works. What about our next one? 3/2 divided by 9. Well, 3/2 divided by 9/1 equals 3/2 times 1/9, which is 3/18. Thus, let's simplify that down, divide by 3 to the top and the bottom, 1/6. And now, last one, 2/12. If that simplifies down, well, that simplifies down to 1/6. So these all simplify to the simplest form being the same. All right, thus, yes, proportional. All right. Now, let's do few more here. Then we'll flip to one other new little thing. All right. Tell whether ratios form a proportion. I want you to do this on your own here, and then we'll come back, but let's simplify this stuff down. 1/2, 5/10 is 1/2. Does 1/2 equal 1/2? Yes. Yes, it's a proportion. 4 over 6 simplifies down to 2/3. Does that equal 18 over 24, which simplifies down to 3/4? Nope. No, it is not a proportion. All right. Number 3, something over 1 is never going to equal something less than 1. So, no, not a proportion. Okay. What about this? 25 over 20. Let's divide both by 5. That simplifies down to 5 over 4. Does that equal 15 over 12? Let's simplify both of those numbers by 3. 15 divided by 3 gives us 5. 12 divided by 3 gives us 4. Both simplify down to 5 over 4. Yes, we have a proportion. Okay. So again, simplifying fractions, you've done that before, and so on. Okay. What do we have here? We have tell whether x and y are proportional again. One more in the table form this time. Let's do the same thing that we've been doing. Let's simplify all these fractions. And it doesn't matter if it's y over x or x over y, as long as it is consistent there. So let's do x over y since that's here. This simplifies to 1/12. 2 over 24. What's that simplify down? Divide by the top and bottom by 2, 1 over 12. Okay, 4 over 48, divide the top and bottom by 4, 1 over 12. 6 over 72, divide top and bottom by 6, 1 over 12. So these are all equal, thus, yes, proportional. Okay, so we're going to go to the next page here and do one little bit of new thing. So we're going to introduce the idea here of cross products. That's what books and textbooks normally say. I just call it cross multiplication. But what this says is in the proportion A over B equals C over D, the products A times D and B times C are called cross products. So let's do a quick example of how this is used, and then I'll talk a little bit about the algebra side of it. So let's say this. We have 2/3 and we have, does that equals 4/6. We already know this is a proportion. And the key thing is that both sides are equal. So now when we cross multiply, all right, and what that means is I'm taking the one numerator multiplied by the opposite denominator and vice versa. So 2 times 6 here, does that equal 3 times 4? 2 times 6, 12. 3 times 4, 12. This is true, so yes, it is proportional. So if both sides here are true, we know that we have a proportion. If that was not the case, that is not a proportion. So all those ones on the other side, if you didn't know, let's say we had this here, 4 over 6, 18 over 24. We could do 4 times 24. Does that equal 6 times 18? Well, it won't. But if it did, we would know it was proportionate. And if we didn't, it is not. Okay, now why does this work? It all works because of this equal sign. Okay, and because we know both sides need to be equal. So let's think of this algebraically. If I was to try to get this D up, all right, get rid of our numerators, or the B up, we would multiply both sides by B to start. So let's say A over B times B. That is going to equal C over D times B, right? I'm just putting in numbers here. Well, those B's cross out here, so we're just left with A equals CB over D. Well, now let's multiply both sides by D. Well, that causes these here. A times D is going to equal CB over D times D, and those D's cancel out. Thus, we have AD equals CB. Now, I don't expect us to follow everything since those are just all variables. But the point is, when we're cross multiplying, because it's equal, you do everything to both sides. And thus that cancels out our numerators, denominators, and you're left with the cross products. Okay. So let's do one word problem and then we'll call it a day. All right. You swim your first 4 laps in 2.4 minutes. You complete 16 laps in 12 minutes. Is the number of laps proportional to your time? Well, let's check. There's 2 ways that I may show us here. All right. Our first one, method 1. Let's compare unit rates. So they gave us 2 rates here. And let's compare them. We know we have 2.4 minutes per 4 laps. Let's see how long that is per lap. Let's divide by 4. Divide by 4. That means for every 1 lap, 2.4 divided by 4 means 0.6 minutes. Okay. If this unit rate is the same as our other one, then as the 16 over 12, then we'll be in a good spot. So 12 minutes over 16 laps. Well, we need to divide by 4 again. Or sorry, not divide by 4 here. We need to divide by 16, which ends up being 1 lap. And then with that, 12 divided by 16, well, that is going to equal 0.75 minutes. So these are not the same unit rates, simplest form of the fraction. So no, it's not proportional. Method 2, all right, one more method, and admittedly, this next method is probably easier, is let's do cross multiplication. All right, so I can set up our proportion and ratio, 2.4 minutes per 4 laps. Let's see, does this equal 12 minutes per 16 laps? All right, so let's cross multiply here. All right, does 2.4 times 16, does that equal 4 times 12? Well, 4 times 12 we know is 48. Does this equal 2.4 times 16? Well, that comes out to 38.4. So no, these are not equal. So no, we do not have a proportion. So both of these ways get us to the same thing. All right. Have a great day and hope you all do well. Bye-bye.